So let me ask, yes, Sekandi.
Lord Almighty Father, as we go on today with our people, please help us, may we understand, may we get protected and learn more.
Amen. Thank you for the word of prayer. Thank you for that word of prayer. I think we are good to start. You are going to use the chat for some of these items, and you don't need to write. Oh, yeah, you're going to use the chat for some of these items. So when the question pops up, then for you go on and answer through the chat. Hope my graphs are being displayed well. So respond through the chat. Okay, I've seen in the chat. I've seen in the chat your responses. Okay, good. I'm putting another. Still use the chat. Okay. I've seen some responses in the chat still. Okay, but now I want someone. You raise up your hand and then tell us. We're on justification number 2. You raise up your hand and then you share with us. Anyone? You raise up your hand and then you share. Let me open now to raise the hand. You tap on reactions. Yes, I want someone to share with us your experience, which one you think, which graph best suits you. I don't want you to look at the marks. Don't look at the marks, but I want you to just look at the trend of that graph. Can we have someone? Okay. Okay. Yes, Elena.
Okay. For me, graph.
Yes, Elena, go on.
According to the 3 graphs which are for question 1, I think it is graph. And when I'm to justify my choice with the, for example, my average was around Term 2 decreased to 66.
Okay. Thank you for sharing. Yeah. Now, when you look at these graphs, all of you are somewhere. I've told you don't look at the marks. But when you look at those graphs, you can notice that there is some kind of pattern that each one of you must follow. So I expect each one of you to be somewhere when you look at these graphs. But I wanted you mainly not to look at the marks, not to look at the averages, but to look at how the graph looks like. So when you look at those graphs very well, let me use second is saying in term one, I had a good average and term two tried, term three things worsened. Yeah, so you can notice that he was somewhere. So we are going to be somewhere here. But when you look at these students, when you look at student A, student B, and student C, there is something that they are actually experiencing. Now, question number 3 is telling us that suggest strategies on what the child can do to transform the graph to the desired one in 2025. We can use the hand. You can raise up and then you tell us what you think this child needs to do. Okay. Yes, Joseph. Joseph. Josiah. Unmute.
Good afternoon, teacher.
Yes, good afternoon.
So the strategies one like can do, a child can do to transform the graph. That the graph, like in B, the child doesn't have to relax. He has to put in more effort, focusing, reading books.
Okay. Thank you. Atuhire. Atuhire. Unmute.
I think for the candidate or the student to improve, they have to put the following in consideration. They should read their books more, consult more, and not be scared to ask questions where necessary. Because sometimes these questions that we have, if you keep them to yourself, you may end up keeping a wrong answer to yourself. When you ask the teacher, it can be easier for you to know whether your answer is correct and even know the answer to your question.
Okay. Thank you. Risi. Unmute. Oh, I'm failing to get. Any of those people have asked Techno and Risi? Okay, I think I've failed to do. So we are going to be relating to these graphs. But one thing I wanted you to identify is that when you look at the first graph A, you're noticing that this person worked so hard and the performance went on increasing. Whereas when it came to the second person, you notice that this person, the performance was decreasing. At first, he put in a lot of efforts, but because he was not consistent with the actions and the efforts, as much as he was an able child, the performance went on decreasing. But also there might be other factors. Whereas when you look at the third person, you notice that this person, the average was constant. He did not improve, he was there. So that is what we are going to be looking at in this topic. And at the end of this topic, I want us to. Now, I have something I've displayed, and I want to know through the chat, our first activity, whether you have ever seen such signposts anywhere. If yes, please go on and mention the places where you have seen them. Can we use the chat? Yeah, so be active. Type in the chat quickly. In case you have never, say no, I have not. In case you have ever, then kindly let us know. Hmm. Okay, never along the Lord, I have ever, no, the Lord sides. Okay, now I want someone who has ever seen them somewhere to raise up their hand and you share with us where you saw that signpost. Yeah, it can be in Uganda, outside Uganda, as long as for you have ever seen it. It may not be the exact one, but something similar to that. Okay. It seems along the roadside. Yeah, many of you are saying at least you have seen them along the roadside. Have ever on the road? Yeah, I think never. Okay, yeah. So I know some of you might not have seen them. Some of you may have seen them. Given that you are an observant person, if you are not very observant, then it means that you might not have interacted. And what do you think is the significance of those signposts on the road? Can someone raise up the hand and you share with us? What could be the significance? Why do you think they put them on the roadside? Particularly these ones. Okay, yes, Morris. Morris, unmute. Okay. Hannah, unmute.
Yes, good afternoon.
I beg your pardon?
Good afternoon.
Good
I think
afternoon.
these, I think these signs are put there like to prevent accidents, not like signs like slow down. And also there are some signposts that have like a specific amount of kilometers. So I think mainly it's to prevent road accidents. Yeah.
Okay. Thank you for sharing. Josiah and Sanyu.
Specifically, these road signs are like this one, like a zigzagger, like it can indicate that where you're going, there's a sharp corner, so don't like speed. And then the one that down there as a log here now, it means like to decrease the speed.
Okay. Thank you. Yes, Sanyu.
So basically, I believe that the significance of the signposts on the road is to protect the citizens and the pedestrians, plus those using the vehicles, in order to ensure that they are safe. But if you look at these pictures, most of the signposts they have showed prove that it's like going down the hill, and the percentages they are putting, meaning you maybe the people in the vehicles have to decrease the speed they are going on by that percentage. That's my opinion, sir.
Okay. Thank you so much. Then the last one, Rashida. Yes. Okay. Rashida. Okay. Yeah. Okay. Thank you for sharing. Okay. I have another question. What safety precautions would you advise the driver to take when such signposts are encountered? So those raising up the hand, that is the question we are answering. Yes, Aitel. Yes, Aitel.
For example, after seeing a signpost and interpreting what it means, you should know what to do. For example, that one with 10%, it says that it means that with, okay, like every 1 foot, there is a 10% rise. There's an increment of the grade of the road, like it keeps on going high every 1 foot. So as a driver, if you know you're not well experienced on steep roads, you as a driver, you should maybe take another route.
Okay. Thank you for sharing. Catherine? Catherine? Or Tekino? Any of you?
Good afternoon, teacher.
Yes, good afternoon.
For me, I advise drivers to always, when they know the road signs, like this one, which is just like it is bent. It shows that in front where you are moving or where you are going, there is a hilly place, so you should slow down in order to prevent accidents.
Okay. Okay, thank you. Yeah, that is okay. Which areas in Uganda would you recommend installing such signposts and why? Those who have been in Uganda and you have traveled. I'll start with Joseph.
According to me, teacher, I think in Kasese because they have highlands and yes.
Okay, in Kasese because they have highlands. Okay. Cather,
In here, in here areas.
in Hire areas. Okay. Hannah, Montana.
I think they should put these signs in like places with roundabouts because some people like when you say for example someone did not is a roundabout, they can easily their cars can easily collide. So I think some people should be put in places with roundabouts.
Yes.
Okay. Thank you for sharing. That is very, very fine. Okay. Now, I want you to bring it to your attention that whereas in Uganda, or you may not have seen some of these signposts, but it is very important as a student because I know one time you are going to be driving, and I know some of you know how to drive. But whenever you meet such signposts like people have shared, you need to read it. Now, these signposts are mathematically designed. So meaning that your knowledge of mathematics should help you to interpret them and do what they say. So whenever you meet such a signpost, you see 10%, 30%, 1 to 8, 8%, and the rest of that. It is an indicator that where you are going or where it is, there is always maybe a slope, and mean that if there is a slope, you need to slow down the speed you are moving at. In case you have been at 180, then you need to slow it down to a speed that is a bit low. So what we are going to cover today is going to be rotating around this. So I'm showing you the application of the mathematics we are going to learn today and where you will use it. Okay, I have other pictures here and my first activity is there. So you raise up your hand and then you describe what you think is taking place in the picture. Okay, I start with Mercy. Mercy. Oh, Mercy is not unmuting. Drusilla. Oh, Drusilla is also not. Yes?
So for the first picture, a man is riding down a hill. For the second picture, a man is going up a hill on a motorbike. Then for the third picture, man is riding the bicycle on a road. So I think it's just mostly cycling.
Okay, good. Then we shall have Goletti or Islay. Oh, Islay. Okay. I'm failing to get the person, but I can look through. Okay, looking through the chat, some people are saying they're riding down, cycling down a hill. Okay, yeah. Okay, the answers are okay. The answers are good. Okay, I have another question. Another question is here. Compare the speed and the effort required for each person in the picture. I want you to just compare and then you tell us what you think. I will start with Islay. Patrin.
In picture one, the person is using less speed and more speed and less effort. In picture two, the person is using more effort since he's moving up a hill. And in the third picture, the person is using a balanced effort since they're in a clear road.
Okay, good. Then Zara. Thank you. Zara. Oh, sorry. Zara, unmute.
Unmute. Picture one, less effort is needed because the person is driving downwards. And in picture two, where the person is riding a motorcycle, more effort is needed because of gravitational pull. And in the last picture, moderate effort is used because it's not a hill and it's not a slope.
Okay, perfect. Yes, okay, thank you. Okay. Please, I want you to have these mental pictures because what we are going to be covering, we require to remember them. I will be referring to many of these pictures. Anyone who has ever seen this, let me know through the chat. Or anyone who has ever enjoyed this game somewhere. And if you know even where you can find it, someone can raise up the hand and then you let us know where you have seen it, whether you have tested it. Okay. At Hiri.
I've ever seen this at a water park.
Okay, at a water park. Okay, and what's the name of that activity?
I don't know the name of the activity, but it's mostly used when you go to the water park. When kids go there to enjoy, you go from up and then you push from down. And then they
Yes.
push you down.
Oh, okay. Yes, Hannah?
Well, I've seen this at a swimming pool. It was like this large pool.
Okay, yeah. Now, whatever you are seeing here in the picture, when they are designing them, you must have the mathematics. They require to have the mathematics. So, those who have been to the source of the of River Nile in Ginger, you must have made something like this, whereby someone comes from up and they push you, then you gonna fall into the water body. I think these are bouncing castles. Many of you have seen them. And I think recently, I think that I had a case where I have had a case where people were saying some people died, something like that, when they were using it. So these are mathematical things. When they are designing them, they must put the mathematics in the head. And this topic we are going to cover will require us to know about where we shall use them. Those who have been to Freedom City, I'm seeing through the chat that some of these activities are there. Leisure Park. Yeah, and I think it is something whenever you get time and you can have some resources, you can go and enjoy. Okay, now when you look at my figure, I'm showing you the different kinds of slopes we have. Uh, when you are going up the hill, that is the first slope. When you are going up the hill, we have this kind of slope. And this one is related to the other gentleman that was on a motorcycle. So there you use some kind of energy. And whenever you are putting in energy, it means that whenever you're putting in, that one we shall be calling it something positive. Whenever you're going up a hill, you are putting in energy. When you are coming down, here less energy is needed. So that's why we are calling it negative. Even if when someone has been like sweating, when you are coming down, at least you are calm. So here you are reducing the speed. So when you are going down the hill, we call it negative. Then there are some times whereby you're on a flat road, you have relaxed. So that one, it is just 0, or what you call the flat surface. But also there is another one where you're going up directly. But this one is always very hard for someone to walk vertically like this, like this, like this without falling. So this one, it does not exist. So there is no any vehicle that can go straight like this when you are moving vertically upwards. And now these are the 4 slopes that we are going to look at in today's lesson. So when you go back to these ones, I want people to put in the chat, which kind of slopes are these ones that are displayed here in the chat quickly. I've showed you 4. I want people to tell us through the chat. Maria is saying negative. What about the rest? Okay, people, so that is negative because you are losing some energy. Now we go back, I want people in the chat still, we are using the chat. This is part A, this is part B, and this is part C. Feel free to abbreviate. I want you to tell us which kind of slopes are these ones, A, B, and C. Type in the chat. I want you to learn how to type. Don't mind about which topic. We are yet to get there. Which kind of, you tell us A is this, B is this, and C. Okay, A is negative. Okay. Yeah. A is negative, B is positive. A is negative, B is positive. Okay. Okay. Yeah, at least I'm happy people have been able to notice what we call a positive and what we call a negative. Yeah, yes. Okay, people are saying, okay, at least that is very good. That is very, very good. Okay, now I'm going back still to the pictures again. We had some pictures here. We had some pictures initially. When you look at these graphs, I want you in the chat to tell us whether yours was a positive, whether it was negative, or it was, I don't know. Your performance, was it positive, negative? I want us look at the nature of the graphs. A is positive. Okay. Okay. Neutral, positive, 0. Okay. Yeah, so that's what I wanted you. Now, as we dive into today's topic, I want you, you need to know what we call a positive, what we call negative, and what we call 0, and what we call undefined. And today, in our topic, this is what we are going to be looking at. Whenever someone is climbing a slope, get me well, whenever someone is climbing a slope, this is what we have called positive. So whenever your slope is positive, your line mathematically will resemble what you have in the picture. Whenever you are dealing with something positive, your line will look like that. Whenever you are dealing with something negative, your line will look like that. That is negative. Whereas when you are on a flat surface, your line will always look like that. And therefore, today's lesson, we are going to look at what you call the equation of a straight line. And this is now the topic. So let me ask you now to write. And in this topic, what we are going to look at, what we call the slope. So the thing we are going to concentrate on is called the slope. So you write the equation of a straight line. That is the name of the topic. When you finish, let me know through the chat that we can continue. Okay, people have finished. Okay, and our learning outcome that by the end of this lesson, you must be able to state and find the gradient between 2 points. Now, mathematically, I've been using the word slope, but mathematically, slope in mathematics is what we call gradient. So when I'm talking about slope mathematically, we call it the gradient. So when you are calculating your gradient or finding the gradient, it can either be a negative, it can be 0, or it can be a positive, or it can be undefined. So how do you write gradient or mathematically? So this is how you are going to be getting your different gradients. And always whenever you find the word gradient, it means the slope. Are you going down? Are you going up? Or are you on a flat surface? So you need to remember and put this into consideration. So all those pictures I've been showing you, I want you now to know that whenever you see something going down, the answer I am supposed to get is a negative. Whenever someone is going up, the answer I'm supposed to get is positive. Whenever something is flat, the answer I must get must be a 0. So that is what now I want you to know. But what is gradient? I am going to use this symbol. When you look at this sign, what does it mean? It means that for every, I want you, don't write, I will tell you when to write. When you look at this, where you have the 4, this is what you call the horizontal distance. When you look at this upper one, is what you call the vertical distance. Now, what does it mean? So when you find such a sign, it means when they put 25%, it means 25 out of 100, which when you reduce, you get 1 out of 4. So it means that the upper number represents the vertical. The lower number represents the horizontal distance. So what does it mean? It means that for every 1 unit you move vertically, you will move 4 steps. That whenever you move up one step, it means you have moved a distance of 4 steps. So that is the meaning of those signs. It means that when you find something like that, it means that you are going upwards, or there is a slope you are going to meet. That for any 1 step you go up, down, you would have moved for a distance of 4. Those who are going to be doing architecture, those who are going to go into civil engineering, when you are designing those structures for buildings, even the roof you are seeing at your house, whether you have that roof they put on the house, also they apply the knowledge of gradient. You must know, because there are some angles which when the percentage is very big, you'll find that you can never collect water on your house. Take an example. In case your house is tilted like that, it means here the angle it means that this percentage is very big. So you'll find that here, when water falls from your roof, it will just be coming here. And if it is very sharp like this, it means you may not. So that those roofs are always tilted at a given percentage. But you'll find all that knowledge through this particular topic. Kindly let me know in the chat whether we're on the same page. Yeah, I want to know whether we're on the same page and we are good to continue. Okay, Maggie is saying yes. Yeah, I'm looking through. Okay. 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 It is okay. Now. Okay. Okay. Now, we are going to look, I want you, now I'm coming. I want you to take 2 things. One, whenever you're finding the gradient of a line or anything concerned with a gradient, always we get the change in height out of the horizontal distance, or you get the rise out of the run. So when they talk about the rise, this is the rise. And when they talk about the run, they talk about this. So may I ask you to write those 2 formulas? write those two formulas, and then we are going to look at the calculations. Yeah, those people who are not yet on the same page, I know where the problem is. Yeah, we are going to look at, I know you are so much interested in the calculations, seeing things, doing numbers and the rest. Yeah, so that's where the problem is, but we are going to do, and you'll be able. But what I want you to know is the application. I don't want you to study something and at the end of the day, you don't use it anywhere. Okay, so people have told me they have finished. Okay, now I want us now to pay attention to how we obtain the gradient. So we have said that in order for us to obtain the gradient, we always get what we call the rise out of the run. Now, what is the rise? This is our line. So always what you have to do is you must create what you call a right angled triangle. What am I going to do? When you look at this line, I am going to create a right angled triangle. So I'm going to come and I create one. But I want you always identify any 2 points along that line where they want you to get the gradient. So I can identify this point here and identify this point here. After identifying those points, I am going to go on and I find my gradient. So what do? You always construct a right angle triangle. So I'm going to come, I do like this, and then I do like this. So this is my run and this is my rise. After doing so, always observe the scale given. You are noticing that every one box here has 1 unit. Every one box has 1 unit. So you ask yourself, here, vertically, how many units do you have? I have 1, 2. So this is 2. Then horizontally, how many units do you have? That I have 1. So I'll come here and I say, my rise is a 2 and my run is a 1. And therefore, after I do, I say 2 divided by 1, I end up with a 2. Then I look at the nature of the line. When you look at the line, we say that always lines that go like this are positive gradient, or the slope is positive. You are putting in energy. You are climbing a hill. So here your answer will be positive. So but mathematically, there is no need for you to put the positive, but you need to know it in your head. Alternatively, whenever we are dealing with the Cartesian plane, whenever you move towards the right, you are moving in the positive direction. Whenever you move upwards, you are moving in the positive direction. When you move downwards, you move in the negative. When you move to the left, you are going to the negative direction. So here it doesn't matter, please. Always feel free. As long as you are able to form a right angle triangle, another person can come and say, me, I'm interested in using a point, but I want you always to look out for those points that are going to be easy for you to read. Another person can come and say, for me, I want this point here and maybe this point here. That is very fine. So what do? I'll come here, I draw my right angled triangle that I'll move in this direction. Once I reach here, I go up like this. So after I'll go up, then I'll come back and I ask myself, how many units have I moved upwards? That 1, 2, 3, 4, 5, 6, 7, 8. So here I'll have 8. Out of, what about the run? I've moved 1, 2, 3, 4 complete boxes out of 4. So still my answer will remain at 2. So it doesn't matter as long as you draw the right triangle. Even if I come and I say from here and maybe here, so it will come still, move, as long as you form a right angle triangle. So here I can say, I'm going to move upwards like that. Then I move horizontal like that. Then I ask, how many steps am I moving up? 1, 2, 3, 4. So I'll say up, I have moved 4. What about the other on the run? I've moved 1, 2. So here, divide by 2. Still the answer you get is 2. So whatever, as long as you have drawn the right angle triangle, and you must be able to know that now my graph is moving in that direction. May I know through the chart whether we're on the same page? How do you know, Martha, it is positive or negative? We have said that whenever you are climbing a hill, that is the positive. Whenever you are coming down, it is a negative. Yeah. Okay. I think we're on the same page. Okay. Okay. The counting part. Now, the counting part, I want you always to be able to count those, I call them the squares. Don't look out for this smaller one. Let me say, some of you may want to complicate life. And you say, you look out for something. Always look out for something you feel is going to. Now, take an example. Someone chooses here and maybe here. When you look here, when you draw your line, you will come like this and then you have to go up here. So you may fail to know that a box here has 5 small boxes. So if you are able to count that from here up to here, those are 5, and that is 1 box, that from here up to here, those are 2, then it is okay. But though I don't advise you, I want you to always look out for that triangle that will be easier for you to count how many you have. Okay. Okay, allow me to give you, oh, yes, I have another one here. Can everyone first try for me? Yeah, feel free, you try it. Yeah, there is no need for you to write in a book. Yeah, but I want you to try out the way you're seeing it on the screen. I want you to draw your right angled triangle, and then you tell us which answer you are getting in the chat. Yes, the distance you move, always count the number of units. One answer, one people saying one. Okay, seems people are getting one. Okay, it seems people are getting one. Okay, now I can. Now for me, can someone put the hand up and then you tell us, I want you to just tell us the points you chose, or you tell us the coordinates and then we draw the triangle together. Yeah. Someone just have your hand up. You tell me that I considered this coordinate. Okay. And Prudence.
Yeah, for me, I took 1 and 4 as my
1,
coordinates.
1 and 4. Oh, what is 1 and 4? Of
Positive
because
1 and positive 4.
positive 1 and positive 4 here.
Yeah.
Mm-hmm.
Is it positive 1 and positive 4? Yeah.
And which other point? Remember, the points you are going to take to draw your right angle must be on the line, on this red line. So 1 and positive 4 are not. Oh, okay, sure. Yes, Lorena?
Me, I chose +2 and +2, then +5 and +5.
Okay, thank you. That is very okay. So you can notice that she's going to come, she'll move like this, horizontally. When she reaches there, she goes up like that. So in order for us to get the gradient, we have said you always get your vertical. So here, you notice that this is 1, 2, 3. Out of here, you have 1 box, 2 box, and 3. So you end up with 1. Okay, can we have another person? Don't take the same point. I want now someone else. Morris Batabaile.
Always, that man is from giving the answer.
Morris?
I gave 2, 2, 5, 5.
I I
You said
choose
12.
positive
It's
5,
done which
positive
the
5.
teacher's
You
doing
use?
here.
Positive 5, positive 5.
And then?
And then I divided it, so I got 1.
Not, not really, because I want you have first form a triangle.
2, 2, 5,
Yes,
5.
I form a triangle from gradient 5 to 5.
Where did you start from? This is 1 point.
0. 0.
From 0 to 5. Then I went to the y-axis, so I went to the 5.
Okay, though I have not got the triangle I wanted. I want you must form a triangle. Okay,
0,
let
5,
me
0, 5.
go right.
Okay.
Yes, go right. Yeah. Now, what I want you always to do, please make sure you look out for 2 points before you come up with a triangle. Come up with the 2 points. Another person would have done like this. You'll come, you say, I have gone like this, I have gone like this. So you show how you have moved. I have moved horizontally and vertically. Another person can decide to say, me, I want to start with from here up to here. So you show that I've moved from here and I've gone here. So you find that here you get 6 out of 6, which is still a 1. So that's how I want the triangles. So for any coordinates you use, as long as you have picked 2 points, you'll be able to obtain the gradient. Okay. Now we are going to do another one. Now, when you look at this one, I want you to be observant. We have already said, now let me even test through the chart. Mere looking at our line, can you tell me, is your answer going to be positive or negative? Mere looking at the line. Type in the chat quickly. Is your answer negative, positive? Perfect. Perfect. I think now we are almost on the same page. So your answer is going to be negative. So that's why always, I don't want you to fail something when even you know what you are supposed to get. So for me, let me choose. In fact, I have already mine. So I can take on this point and this point. But I want you to be observant. I'm going to show you 2 ways how you can do it. The first one is for you to count that here, this is my horizontal, that is 1 box. When I look at vertically, I have moved it 2. So my answer for gradient is going to be 2 out of 1, which is 2. But since we have said this one is negative, I'll put a negative. Alternatively, someone can say, how are we going to move? Now, I want you to pay attention how we move when the slope is like this. I'm going to move like this. We have said that whenever you are moving to the right-hand side, that one is a positive direction. Whenever you are moving downwards, you are moving in the negatives. You are noticing here, when you try to move down, you are going in the negatives. So here, you'll have negative. So when I move to the right, I have moved 1 step. When I go down, I have moved negative 2 steps. So negative 2 shows you that someone is moving downwards. So that is the meaning. So if then that means that your gradient is going to be your rise, which is negative 2 out of 1, which is negative 2. So you can use any of the approaches. In case you have a question, kindly you can raise your hand in case you have a question you want to ask. But in case you have understood, kindly let me know through the chat. Okay. Vivo.
Sammy, I'm still lost when they use a positive or a negative.
Okay. Now, Vivo, we have said that when you are climbing a hill, that's what you call a positive. Do you know climbing?
Yes.
Now you should tell me, this is my A and this is B. Of the 2 lines, which one shows that you are climbing a hill?
B.
Really? Now, okay. Now, when you are climbing, you'll be like this. You'll put in efforts. You'll take this direction. When you are going down, you come like this. So whenever you find that your line is like this going downwards, that is the negative. When the line is going like this, is a positive. But do not cram that. I've showed you another way. I've told you that when this is the line, you are not seeing it. If that is the line, I want you always to look at the points. When you look at these points, someone can decide to move like this, and then the person moves up like that. Now, whenever you are moving this side, you are moving in the negative direction. Whenever you are moving up, you are moving in the positive direction. Is that fine?
Yes.
Now, when you look at this graph, let me take this point and maybe at this point, I'm going to move like this. Tell me, how many steps have I moved? How many
Pardon?
steps are you seeing here? How many steps have you seen that have moved to the left?
1.
1, eh? But since I'm moving in the left, I'll put -1. Is that fine?
Yes.
Now, I'm going up. When I reach here, I'll move up like this. So, how many steps have we moved up?
2.
2. Is it +2 or -2?
+2.
Positive. So then after I will say gradient is equal to rise out of run. So my rise has been 2 and my run was -1. So 2 out of -1, I'll get -2. Is that fine?
Okay, thank you, sir.
Okay. Okay. I pick one more hand. Martha? Martha?
Good afternoon,
Martha
teacher.
asks.
So my question is, will they always be giving me will they show me the arrow, the direction where I'm supposed to draw the triangle?
No. It is you to like Martha, it is you to come up with it. Look, depending on the line. Are you getting it?
So it can be
It can? It can be? Oh, Martha, I lost you. Martha, what are you saying? Oh, yeah. So, Martha, I've
I'm
not
saying,
picked.
so my answer can be a negative or a positive.
Yes, it can be positive or a negative, but it depends on the nature of the line. Are you getting it? Okay. Hope. Yeah, the rest we are trying out that number. Martha, your network is really disturbing. I can hear a few words. Yes, Zara?
Sir, I was asking if the line is on the right side, then it is a positive. And if the line is on the left side, it's a negative. Am I right?
Not really. I don't know what you mean by negative and what you mean by positive side.
I mean a positive slope and a negative slope. Because now the first two examples you gave us, the red line was on the right side, like on a positive slope side. And this other red line is on the negative side. So
Not really.
does it?
Martha. Okay, you keep on. Zara, are you seeing? Our line can as well be here. Are you seeing?
Yes.
Now, when it is here, let me say this is 0. This is -1. This is -2. This is -1. This is -2. In case I choose this point and maybe this point, Zara. Now,
yes,
I'll ask myself the right angled triangle. So I can move like this and I move like this. So I've moved like this, I have moved like that. Is that fine?
Yes.
Now, when you look here, how many steps do you think we have moved on the horizontally?
2.
Okay, 2. Then vertically?
1.
Okay, 1. But here, when you compare to what I've drawn, it is just 1. Allow me to use 1. Yeah. So you
Okay.
notice that here, your answer is going to be 1 out of 1, which is a 1, which is still a positive.
Yes.
Yeah. So what determines the negative or positive? It is the nature. Whenever you find that the line is like this, that is, the answer will always be positive. When you find that the line is like this, no matter the quadrant or the side where it is, the answer is
Okay.
negative.
Okay. Thank you, sir.
Okay. Okay. Heather?
Teacher, I wanted to give the answer.
Oh, for this one, Okay, which answer do you have?
I have -2. I had my change in height as -2. Then my horizontal distance was 1.
Can you share
And
with us which points did you use on this line?
I used 0, 4, and
0, 4? 0, 4 is here.
no, okay, -2, 4.
Okay, -2, 4 here.
Then I drew my line and that became the horizontal distance.
Up to what? You did like this?
Yes.
Then
I drew
downwards?
yes, going downwards.
Like that?
Yes.
Okay. So what was this horizontal distance?
2
2. Then this one?
was -4 because it was going downwards to the negatives. Then
Good.
I divided and got -2.
Okay, perfect. It is correct. Okay. Hope everyone else, you have -2. Kindly let me know through the chat. Yeah. Yes. And prudence, that is okay. Yeah. Always, Zainab, it must be a rise out of a run. Members, are we good to continue? Is the concept in the head? Okay. 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 At least good. I've not seen any no. Okay. Yeah. Okay. Now I want you to summarize. Yeah. This is what I want you to write in your book and summarize. So let's summarize. So when you finish, you let me know through the chat. I'm seeing a hand up, Zion and Hope.
Yes, teacher. You said that that's right. On the previous pages, hello?
Yes, I can get you.
On the previous pages, the line, the gradient, when it was on the right hand side, it was positive, and then on the left hand side, the answer always had to be negative. So I'm asking, how do you know the direction where the the right angle is supposed to be? For example, if the line passes through, can you go to the previous slide for me to
Okay, you talk.
straighten?
Let me first listen, then I'm going to, first
No,
complete.
like I need the graph to show you exactly what I'm trying to say.
Can you just keep on a bit, don't mute, such that when people complete, we can go back.
Okay.
Don't mute, leave your mic on. Yeah, but one, as I can be responding to you, I've not said that when your graph is on the negative side is negative. When it is on the positive side is, no. Your graph can still be on the positive side when it is negative. It can still be on the other side when it is negative. So that for quadrant thing, I've told you that one, eliminate it from your head. What determines the nature of the graph I've told you, is how your line looks like. It doesn't depend on the quadrant where your line is. Your quadrants can be like this, but when your line is here. So since this line is sloping, here your answer will be negative, even if it is in the positive quadrant, even if it is here. But it can be here in this quadrant that you are calling the negative. But when your line is like this, here your answer will be a positive. I don't know that that is okay.
Yeah, I understood that bit, but what I'm trying to say is that you see when the line is drawn, how do you know which directions to take when you're making the right angle triangle?
Okay, take an example. This is my line. I've chosen a point here and a point here. Not so? This is point A and this is point B. Not so?
Yeah.
Now, when you are moving, here you are going to ask yourself, how can I move from point A to point B? So when you are moving, you can either say, I'm going to move down like this, and then I go like this. Or I'm going to move like this, and then I go down. Is that fine?
Or you can choose.
You can choose. But whatever path you use, you'll get the same answer. Even
Oh,
if
okay.
you say that this is my point A and this is my point B. Even if you say that now for me, I want to move from B, you move like this, then you go up. Or you can say, let me move like this, and then I go like this. Whatever path you use, from whatever starting point you use, as long as you are moving from one point to another, you'll get the same answer.
Okay, thank you.
Okay. And now this is the same knowledge you must relate to your vectors. you covered in senior 2. Yeah. Okay, has everyone finished? Okay, looking through the chat, people are telling me yes, yes, yes. Okay. Okay. Okay, I think we are good to continue. Now, we are continuing. You write the formula before we start on the, write that formula. But I'm seeing a hand up. Yes, Hope person. Oh, Hope has muted. Alexa?
Teacher, I have a question.
Yes.
You see when you draw the graph and then the line is drawn like in the negative side, is it a must for the answer to be a negative or it can also be a positive?
It can as well be a positive. What determines whether your answer is negative or positive is the nature of the line. Whenever I want you to take you here, people who are writing, allow me to take back. That's why I wanted you to relate to these pictures. When your picture is like this, you are coming down, your answer will be a negative. So that one, you'll find your lines will be like that, like that. Your answer will be a negative. Or if this picture is not bringing out what, it's not making things very visible, allow me to use these pictures. I can come back here. When you look at these pictures should be able to give you the thing that whenever you look at your line, when you look at this gentleman is coming down. In others, you are using less energy. So whenever you are coming down, here your answer will be negative. No matter where your line is, whether your line is here, whether it is here, whether it is here, whether it is here. As long as you are coming down like this, your answer will be negative. Whereas when you're going up, you are putting in some energy, your answer will be a positive. But if you are coming down, you find that your line is like that, then it means you're going downwards.
Okay,
so,
thank you, teacher.
Okay. So let's not look at the what? Yeah, but I'm going to teach you. This is just one approach. Yeah, but why I want us to learn all, it's because it always depends on the nature. Yes, always depends on the nature. Yes, Alex. Okay. Now, we are going to go to now getting a formula. We are going to go to getting a formula. Now, I've shown you the approach when we have a graph. What about when we want to use a formula? How do we do it? Now, if this is my graph, this is my graph. You know very well that for these graphs, this is our x-axis and this is our y-axis. Imagine this is how our line is. And I have a point. Let me call this is my point A and point B. Now, when we are looking at the lines, I can have this one is my x. This one here is my second x. So here, let me first use digits for you to understand. This one can be 2, then this one can be 4. So here, I am going to label them that x1 is the first digit. So here, I'll have x1. Then here, I'll come here and I have x2. Then I'm going to go horizontally. So horizontally, I'll come like this. This is going to be y1. Then I'll come here and I call this one y2. Now, members, let me know whether you have picked how I've labeled. Use the chat, say, yeah, we're on the same page. Yeah, saying yeah. No, 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 yeah, yeah. Okay. Someone has said no. Let me repeat. Let me repeat. Now, let me repeat because I want it to stick. It must stick. Oh, this is my graph. Take an example. I'm plotting 2, 4, and I'm plotting 6, 8. Let me put them on my graph. So this is my 2, this is my 4, this is my 6, this is my 0, this is my 2, this is my 4, this is my 6, and this is my 8. Now I'm going to plot the first point, 2, 4. So, oh, okay, 2, 4 is here. I'm going to plot 6, 8. 6 is here and 8 is somewhere here. So my line is going to look like that. Now, when you look at 2, 2 is your x1. So here where there is 2, I'm going to put x1. Where there is x2 is the 6. So 6, x2 is here. When I go to y1 is 4. So y1 is here. And 8 represents my y2, which is there. Allow me now. Hope that one is a bit better. So allow me to, oh, no. Before I remove it. This is 2, 4, 6, and 8. Now, what is going to happen? Allow me to draw something small here. I'm going to ask you. I come like this. I come like this. Now, here, when I'm completing, I'm going to draw my triangle. My triangle is going to be here and here. So I'm going to move like this. I move like this. Now, I'm going to ask you, from here up to here, how many units do we have in the chart? Put for me. From here up to here, what is the distance from here up to here? I want you to use the digits I've used. I have 8 and I have 4. So what is our vertical? What is our rise? Please, I want you to look at here. Remember, we are not on a scale. People are saying 2, 3, 2, 3. People have not yet. I'm seeing some answers are okay, others are not. I repeat. From here, let me use a straight line. Here, this is 2, 3, this is 4, this is 6, and this is 8. So we are moving from 4 to 8. So I'm asking you, from 4 to 8 here, how many units, what distance do we have? I want you to take into consideration the scale. Yeah. Now here you need to know that one box has how many? Okay. Now I'm getting it. I'm getting where the problem is coming. Now, when you look here, okay. I've seen where the confusion is coming, but it is okay. But here, I want you to know that in order for us to get this vertical one, I'll have the upper number, which is 8, minus the downer number, which is 4. So my answer will be 4. Now, let me ask you now again, what about horizontally? From here up to here, how many units do you have? Here, don't count your boxes. I want you to use those digits, and I see whether people are picking that one. Okay, 6 minus 2. Okay, 4. Okay, 4. Good. I come back in peace again. I am going to draw another one. We must understand that part because that is where the mathematics is going to come from. Here, I have 6. Here, I have 18. Here, I have 4. Here, I have, let me say 14. Members, I want you to tell me vertically, what do you have? And horizontally, what do you have? We start with vertically. Vertically, tell me what is your answer? What is the distance from here up to here? Your rise, what is it? Okay, perfect. What about now, horizontally? Yes, 10 is very okay. Now we go to horizontally. We're on the horizontal now. Okay. Yeah, people have got it now. Okay, now, what are you doing? Meno, what we are doing, we are saying 14 minus 4. Here, you are saying 18 minus 6. And this mathematically is what we call, you are getting the difference. You are getting the change. And now that's where I want to start from to go back to our triangle. Hope people, we are almost there. Now, when I come back here, I've said that this is my line. This one is my y-axis, and this is my x-axis. So when I have here, this is one point, and this is another point. So here, when I call here, I can say this is x1. Here, I can say this is x2. Now, x1 and x2 are representing our values like 4 and 8. When I come here, this is going to be my y1. When I come here, this is going to be my y2. Here, let me say this one can be your 5, this one can be your 10. Now, members, I want you to tell me, what is our vertical? Tell me in the chat. How are you going to get your... now, my question is, how are you going to get the vertical? Use the figures. Don't give me the final answer. I want you to show me how you are getting that answer. What are you doing to get the answer? Okay, that's what I want you to type. Type that, ta-ta, I get the answer. Perfect. People, yes. Now, instead of using digits, can you please use y1 and y2 and type in the chat? Instead of giving me your 10 minus 5, can you? Yes, yes. I think we are there. Now, to get this one, you have said y2 minus y1. Similarly, to get this one here down, you have said x2 minus x1. Now, can everyone write for me in the chat, what is the formula for our gradient? I want you to still to use y's and x, these y's and x. How is that formula going to be? How is our formula going to be for gradient? Ruth, I think your network. I want, okay, okay, Alex, good. Good, good, I'm saying, yeah. Pythagoras is not going to work. Okay, at least. Okay. Okay, so we shall say that our gradient will equal to rise out of run. So our rise is y2 minus y1 out of the run, which is x2 minus x1. And this is our gradient. But also allow me to tell you that here I use gradient, but in books, when you are reading some textbooks, pamphlets, whenever you find letter M is the one that represents gradient in most cases. So whenever you find M, it means it is gradient. So this is going to be an important formula we are going always to use. And please, we don't hear interchange. Always it is rise out of run. So always it will be change in Y out of change in X. Change in always, 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 always. Kindly let me know through the chat. Have we understood that formula? Let me know through the chat. Have you picked something now? Chantal said yes. Martha is saying yes. Katotone, yeah. Okay. If they're not, I'm saying some are saying yes. Okay. Okay. Okay, yeah. Now, those who have not picked, I want you to always know that gradient is given by change in the values you have along the y, divide by the change in the values you have along the x. So when they talk about the values along y, you always say it is going to always be y2 minus y1 out of change in x, x2 minus x1. In other words, you are always going to be just getting the y values divided by the subtraction of the x values. But I want you also to know that here mathematically, in some books, I don't want you to cram. Don't cram. Some books you'll find them having y1 minus y2 out of x1 minus x2. So when you decide to start with y1, 1 minus 2, down also you start with 1 minus 2. When you decide to use 2 minus 1, also down use 2 minus 1. It's just a matter of the negative. May I ask you now to summarize in your own way? The way you have understood is what you should write in your book before we start. The way you have understood is the way you should write in your book. I'm giving you 2 minutes. Write it the way you have understood that formula. As I pick this hand. Yeah, is it Rina? Yes, Rina?
So teacher, I have a question.
Yes.
Here, in this process of getting the gradient using the y stuff and y minus y divided by x minus 2, x1 minus x2, it's not corresponding with the first formula you gave us, which is rise out of run, because here the rise is not connected to the y's. It is
First
the
tell us what is
vertical.
our rise?
We don't have the values for the rise. It
The
is
rise.
like the C part of, if I try to use Pythagoras theorem, it is like the C part. We don't have the values.
Oh, now one thing, no, for Python, your C is here, if you are using Pythagoras. And for C, always remember, C is that slanting one.
Yes, and it is the rise.
No, the rise is the vertical movement.
Oh, so it is, but again, so it means this formula of rise divided by run is not corresponding with the formula of change in height divided by horizontal distance.
It is corresponding. You look at our height. What is our height for here?
It's y2 minus y1.
Which is the rise, not so?
Yes.
Then the run?
It's x1, x2 minus x1.
Which is the horizontal distance here, the run.
Yes.
So does it correspond?
So
Yes.
in the equations, we are not supposed to apply anywhere the C part.
The C, yes, because it is that C that you are finding. How far it is what you want to find.
Oh, I understand. Thank you, teacher.
All right. So you want to find out how steep is it. When you say big percentage, you know that thing is very steep. You need to go slow. Yes, Goretti.
Excuse me, sir. Excuse me, sir.
Yes, yes.
After getting this answer and you divide, is it a positive or a negative?
Now, when you are using a formula, it will just come out automatically. You don't need to do anything. Are you getting it? Yeah.
Yes, thank you, sir.
Okay. Jeremy?
So I have a question.
Yes.
How is the midpoint connected to the gradient? Because I remember they used to have a concept where you use gradient to find the midpoint.
Okay, now that one, those are the next lessons. We shall look at what we call perpendicular bisectors and arrays in our next lessons.
Okay.
Okay. Okay, now I'm going to take you back. Okay. I want to just take you to one question we have done, and this is the question. Now, oh no, this one may not bring out the picture very well. Let me take you to what I wanted. So you may get, okay. So please, I want you always do not forget when you are summarizing your work, take note of these key ideas. I want you to take note of how your graphs will always look like, be it in math, be it in physics, be it in what. So, and always, please, the moment this year, your graph, let it be this positive gradient. Positive gradient means that you are improving year in, year out. The negative gradient means you are declining in performance. Positive gradient means you are improving in the performance. Negative means you are declining totally. So you choose wisely where to go. Now, okay, here, okay, here I wanted to just know about the slope, but I want us, allow me to just go because I want us to look at this. Okay, we are going to try number 1, part A. I do 1, you do 2. So part A, I have 7, 2. This is one coordinate. The second coordinate is negative 13, 10. Now, when you are labeling, please, it is up to you how you want to label. But do not forget our coordinates are always x and y. So what are you going to do? You're going to come and say, this is x1. This is y1. This is x2. This is y2. Please, the order, it doesn't matter whether you have started with x2, y2, x1, y1. It is very okay. Now, after that, we go to gradient. So I will say my gradient, but I've told you gradient, we represent it with m. So I will say my y2 minus y1 out of x2 minus x1. Now, when I look at my y2 from the question, from here, how I've labeled is negative 10 minus my y1, which is at 2. Divide by x2, which is 13, minus x1, which is 7. Now I go on with mathematics. Negative 10 minus 2 is negative 12 out of 13 minus 7. So you ask yourself, 13 minus 7, what do I get? That I get 6. So when you divide negative 12 by 6, I'll get my negative 2. And this is your answer. Kindly let me know whether we're on the same page. I want to just know, are we on the same page? Am I on my own page? Fauzia said yes. Isaac, yes. Yes. Yeah. Okay. I think this is okay. Okay. Perfect. I've not seen any no. Can we now our task is to do now. Oh, Paul is saying no. Paul, raise up your hand. I pick you. The rest, Lydia said sure. The rest, we are doing part B. Do for me part B. I want to pick, Alex Duke has finished part B, it seems. Alex got part 3. I want to pick Pearl. Pearl. Raise up your hand. Help. Do you have a question? Those people who have questions are the ones I want now. Pearl, kindly unmute. I want to know where you are not getting it. Pearl? Oh. Pearl? Oh. I think Pearl failed. Okay, Linda? Linda? Oh.
Excuse me, teacher.
Mm.
I've gotten a problem with part C.
Patsy? Where
Yes,
is the problem?
I've gotten my answers negative. Negative fraction.
It is very okay. It is very okay. So can you tell us, Linda, what answer are you getting?
Part C. So I got my x2. I made the first pair x2. So I got
So this was your
-1.
x2. This was your y2.
Yes.
This was your x1. And this was your y1.
Yes.
Uh-huh.
So my 3 was negative.
So what? Which formula? Which formula did you use? Y2 minus y1.
Yes.
Okay. So you got 0 minus 3 out of
Yes. 5.
negative 1 minus 5.
Right, okay, yeah.
So 0 minus 3, what do you get?
Negative 3.
Negative 1 minus negative 5, what do you get?
Negative 6.
Okay. So which answer shall we have?
1 out of 2.
1 out
A
of
half.
2. A half. Yes. So that is very okay. So that is like 50%.
Okay.
So please, members, when you get a fraction, don't worry. It is very okay. Yeah. It is okay. Doreen, is it a concern, Doreen?
I want to say the answer for number B.
For part number 2?
Yes.
What do you have, Doreen?
Mine, I've got 2 as my answer.
Okay. 2. We agree with you. It is correct. Is that fine? Yeah. Now I want someone I'm interested in part D and E. Anyone raising up the hand, those should be the numbers. I start with Goret.
Excuse me, sir.
Yes.
I'm not getting anything.
Have you just joined Goretti or?
Goretti.
Like I'm asking, have you just joined now or you have been in?
I've been in.
Okay, so Goretti, where are you getting lost?
From number 2.
Number 2, how have you labeled your points? Have you labeled them? Goretti, don't mute. Yes, Goretti? Oh. Goretti, I'm failing to get you. Okay. I think, yeah. So please do not forget, always first label x1, y1, x2, y2, and then apply the formula. y2 minus y1 out of x2 minus x1. Then you say y2 is 0, y1 is 6. Out of x2, which is negative 1, x. So this will give us negative 6 out of negative 3, which gives us a 2. So let me hope, Goret, you have been able to see where the mistake is. Goret? Okay. Maria, same way.
Part D, I have 0.
Take us through what you have.
I had negative 2 as x, 1. Then the other side, x3 is x2. Then again, y1. Then y2.
Okay.
M was equal to 2 minus 2 out of negative 2 minus 3.
So did you do y1 minus y2?
y1.
No, which formula did you use? Because
That
if you
very
begin...
no, there's a mistake. Sorry. No, on the x, on x2, it's supposed to be 3 that side.
Okay. Like that?
Yes.
Okay. So you get 0 out of
5. It's a positive 5.
Okay, which gives you? Okay, thank you. Now this one mathematically 0 out of 5 means you have 5 friends who have come at your home to visit you, but they're asking for cake you don't have. So definitely you'll not have something to give them. 5 people, your friends have come to visit you and all of them want something, but you don't have what to give them. So that is what it means. Whereas for part E, I want you to take note. Whereas when you have a number, let me say 5 out of 0, this one means, I'm just using this as an example. When you have 5 out of 0, this one means that you have the things in plenty, but you don't have people to give them to. You have your big piece of cake, but you don't have people that you can share with. So that is the meaning. Now, if you don't have people to share with, it means that there is nothing like sharing. You can't share, yet you don't have people to share with. So here there's nothing like it is unshareable. You can't share it. Whereas here it means that you really want to share, but you don't have something to share. So for this first case here, the answer will be 0. 0 out of anything, out of any number is 0. Whereas 5 out of 0, we call it undefined. And that is the scenario I want to give. I've told you for 5 out of 0, it means that you have maybe 5,000, you want to share it with people, but you don't have them. So there's nothing, you have not shared anything. Whereas 0 out of 5 means you want to share people around that you can share with, but you don't have things you share with them. And how do those lines look like? Now, those lines are the lines that I skipped because I wanted you to know how they look like. How do those lines look like? The first line where you have obtained your answer, yes, where you have obtained your answers as out of 0, this is what you get. Your line will always look like that. So it means that there is no gradient. The gradient doesn't exist. So this is where you have got a number, let me say 6 out of 0. So your line will always look like that. So always you just say undefined. Whereas there is the other one where you have got your answer. You are here where you have got 0 out of something. So for that particular one, your graph will look like that. So those are the two things I wanted you to pay attention. How your graph looks like when you have 0, it means you are on like you're on a flat surface moving. Whereas when you are for undefined, it's like you are climbing a tree. Yeah, but you can't climb a tree when your legs are like this. These are your legs here, and this is the person. So you can't move, You can't move like that, like that. Let me hope you have understood the explanation for undefined and for 0. Kindly let me know, because now I want to test whether people have understood in this lesson. Okay. Yeah. So what is important is for you to know what we call undefined and what we call. So for your answer, like where you meet your gradient, you say y2 minus y1 out of x2 minus x1. And you end up with your y2, maybe 3 minus 3. Whereas down you have 4 minus 2. Here you have 3 minus 3, which is 0. 4 minus 2, which is a 2. So for such a case, your answer 0 divided by 2, you get 0. So your graph, it will be just a straight line. Whereas when you have another scenario, this is another scenario. If you have a scenario of this nature, whereby you have y2 minus y1 out of x2 minus x1, and then you have maybe 4 minus 2 out of maybe 2 minus 2. Here, remember, 4 minus 2, your answer will be 2. Divide by 0. So this one, is what I'm talking about, what you call undefined. So for such a case is where you get a line of this nature in case it is graphical. So when you find such a line vertically, your answer should always be undefined, does not exist, is meaningless. Whereas when you find a horizontal line, you say gradient is 0. Don't you think? I feel when I add on more words, I may get some people off. Kindly let me know through the chat whether we are at least somewhere. Yeah, because now we are going to the testing part. I want to test whether at least you have picked something, because there is an activity that I want us to do now in the next 10 minutes. Kindly let me know in the chat whether when we test now you are somewhere. People are saying yes, we are somewhere. Good. Now, since you are somewhere, I have displayed, we are going to do some quiz. Allow me to put in the chat the link. -6 divided by 0. As long as you are dividing something by 0, that one is undefined, does not exist. For vertical line is what you call the gradient doesn't exist vertically if it is a straight line going up. Whereas for horizontal meter is where you have gradient 0. People have started joining. Just click on that link and join. Yeah, click on the link and join. In case they ask you for a code, that is the code for the game. Just click, 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 and join. Click, click, and join. When let me see how many we are now. We are about 121. When we make up around 80, we start. Yeah. Okay, Elio, we are waiting for you. Click the link. You just click the link. Then you fill in the details they ask for. But I know some of you may be saying, we can't. Let me share it also on your group. Those who cannot be able to, who are not able to access. Okay, we are 51. Should we start? Should we start? You let me know in the chat. Or we have people of, what is the code? The code is here, 869787. Those who are failing to get the code, in case your code is failing, go to join my quiz, put in the code in the chat. That is the code. We have said the moment we make 80, the moment we make 80, we start. We are 66, I'm saying. Okay. Code is there. Oh, we have just few people to go. More six, more six, more six people. More six people to go. More five now. Just click on the link. Click on that link in the chat. Four more people. Two more. Two more people. One more person. And then we start. Yes. So, okay. So we are going to start. Our graduate is enough. This is 74%. Okay, we can start.
Separation of hydrogen and removal of oxygen from a substance is the opposite of oxidization. Well, with oxidization, we add oxygen, and you release hydrogen from a substance, and in reduction.
So you can look at the screen to see how you have been able to perform. Yeah, so that's how you have performed. Yeah, and I think, and those are the, like the marks, the actual marks you have got, how many you have. So I will share this on your WhatsApp such that you can check and see. But some of you missed out some questions, I think, due to time. Yeah, but this is good, at least. Yeah, don't you think this is enough for today? Yeah, I think it's enough. So let me wish you a good evening. See you tomorrow for other lessons. Bye-bye. You can unmute. Bye-bye.
Bye.
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 Guys.
Bye.
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 Bye. Good. Tomorrow.
Thanks for the lesson.
Bye.
Bye. Bye.